All right, thank you so much for thinking about this and for sharing with a partner. Let's go ahead and identify two conjectures that we could have written. The two things that we know about lengths of dilated figures is that one, they are proportional, and two, they are parallel. Okay? So let's put up here lengths are, they're proportional and parallel. Lengths with an S. Okay, so our first thing is we can write some equations. We can use our formula for a dilation that says take a length, multiply it by a scale factor to get a corresponding new length, right? So in this case, our original length would be BC. So we could say BC times the scale factor of 2/3 equals our new length, which is MN. Or another way we could say that is we could solve for the scale factor. So we could say BC this is not going to be BC. We're going to have 2/3. 2/3 equals MN over BC, right? So here's a proportion, right? Two ratios that are equal to each other. So how do we know that both of these equations are true, right? The reason why we know this is because this segment right here, MN, is a dilation of BC. MN is a dilation of BC, right? If we dilate B from A by a scale factor of 2/3, it lands on M. So dilating B from A by scale factor 2/3 takes B to M. Okay? And then we do the same thing for C to N. Same for C to N. Okay? And then so what do we know? We know that all distances in dilated figures get multiplied by the scale factor. Okay, so that's a brief explanation of our first thing that we can say. We can write either this formula or we can write this formula, which is basically just saying that our scale factor of k is equal to our new length divided by our original length. Okay. Then the other thing that we could say is that they're parallel, right? So we can say MN is parallel to BC because corresponding sides of dilated figures are parallel, right? And the explanation for this is actually going to come from, I think it's Unit 3, Lesson 4, where we said dilations take lines to parallel lines if the center of dilation is not on the line. MN is parallel to BC because dilations take lines to parallel lines when right, and it would take it to the same line if the center of dilation was on the line. Okay, so two statements. Right? We have this statement that compares the lengths, and then we have our justification, right? And the main justification, the part that you would want to focus on, is that all lengths are multiplied by the scale factor. And then our second statement is that the lines are parallel, And what's our justification for that? Because dilations take lines to parallel lines. Okay? It's in this particular case when the center of dilation is not on the line. So, yeah, that's it for this activity.